Hello, welcome back to Cracking the Cryptic. It is time to go to gas. Go directly to gas. Do not pass go. Do not collect £200 or dollars. We are going to be doing genuinely approachable Sudoku here. 5 puzzles from the gas giants, Clover, Bill Murphy and Philip Newman, from about a month ago on the daily Sudoku channel on the Discord server, and they are genuinely approachable puzzles. Anybody can achieve these if you set your mind to it and give it a go. This is the introduction to variant Sudoku you didn't know you needed, but you do. And we're going to be trying 5 puzzles from it, much in the vein of championship puzzles in a way. We'll try and get the hat times that the gas guys are generous enough to award. So it's 1 hat for a fast time, 2 hats for a very fast time, and a dinosaur if you can't quite make the 1 hat time but you do finish the puzzle. And we'll name the dinosaurs. What we will do is read out all the blurbs from the gas channel and then attempt the puzzles one after the other and time them. That's what I'm planning to do. Before that, don't forget that if you want some harder puzzles, there's some brilliant ones at the moment on Patreon in the Nightmare Sudoku Hunt by Skunkworks. We are getting answers in. Very well done to those people who've achieved either 5 puzzles, which is pretty hard. Frankly, I would say achieving 5 puzzles and getting into the prize draw is as hard this month as it normally is to complete the whole hunt. So measure yourself against that. The whole hunt is 19 puzzles of these nightmare styles. We had a very interesting remark from somebody who's normally an incredibly fast solver saying that the nightmare style was a, what was it? Some sort of swamp to his normal style. And I totally sympathise, actually. I do find it very difficult. So anyway, that's on Patreon. It's good fun, I have to say that. And you can check out our apps, including, of course, Gas 2, the newest app we have, genuinely approachable Sudokus from the same people that we will be solving today. It is very well worth $2 or $3 or pounds. Give it a try. Follow the links to our apps under the video. Now, there are other links under the video to our catalogue, to our merchandise, to Sven's Sudoku Pad, brilliant software for solving these Sudokus. Check it all out. But the first bunch of links will be to solve the puzzles we're going to do today. And you can solve them both in our software using the tiny URL link, or if for some reason that's not available to you, you can try NF Puzzles, and they provide links to both. So let's take the time to go through the write-ups, and they'll include the rules as we go through these. And we start with a puzzle from March the 4th called Consecutive Chains by Clover. And what she says is that a unicursal labyrinth is one that can be traced in a single sweeping motion with no branches or dead ends. These labyrinths aren't meant to puzzle you, rather they're created for aesthetic purposes or to be walked during meditation. Similarly, the little labyrinths in this consecutive chain Sudoku have no dead ends or false starts. They go directly from 1 to 9, although they might meander a bit on their way. Oh, and you'll need to draw them yourself. Normal Sudoku rules apply. Here comes the rules bit. So that's obviously 1 to 9 in every row, column and box. Also, each grey area contains the digits 1 through 9 exactly once each, and these digits must form a consecutive chain of adjacent digits from 1 to 9 by moving horizontally or vertically from one cell to the next. So here we could go 1, 2, 3, 4, 5, 6, 7, 8, 9. In theory, there are probably other ways. The dinosaur, I mean, that was a simpler rule set than I was beginning to expect from the blurb. The dinosaur is a Zen Zuniceratops, and after we've done that, we will go on to puzzle 2, Bent Diagonal Sudoku by Bill Murphy. Hey, you, says Bill. Yes, you, daily Sudoku solver. You should do Sudoku Mahabharat round 3 on Logic Masters India. Well, let's make that round 4 coming up this weekend, I think. This round is mathy Sudoku and irregular Sudoku. I've done it, it's great. Just to get you in the mood, here's something irregular. A bent diagonal Sudoku. Bill places a finger to his earpiece. Huh? What do you mean? Not that kind of irregular. No, it's not an irregular Sudoku. So here's the rules. Normal Sudoku rules apply. Each of the 4 bent diagonals must contain the digits 1 to 9. So you know how in a regular, okay, well, it's not quite the rules. So you know how in a regular X Sudoku, each diagonal would contain the digits 1 to 9, like that. Well, here, each diagonal bounces at the intersection, so it's like that. Sorry about the bad drawing. So that is a bent diagonal, creating 4 diagonals which must all contain the digits 1 to 9. And, well, in the Discord channel, there's a coloured image for your reference. But here, what we will do is show you that that's one of the diagonals. Let's see if I can get my drawing better. Nearly. That's another one. This is a 3rd. And that is a 4th. I have done these in competition a long time ago. Anyway, that is the second puzzle. They are each extra regions. We will go on to Happy Anniversary by Philip Newman. Happy anniversary to my parents, who've been married 42 years. Does this mean they have discovered the answer to the ultimate question of life, the universe, and everything? As established last intro, I never make sequel puzzles. But an anniversary is like a sequel, and if I were to make a sequel puzzle, today's gas is a diagonal Sudoku. Normal Sudoku rules apply. Digits along the indicated diagonals cannot repeat. And, right, the one party hat time is 42 years. I'm assuming that's a joke. And the dinosaur is an Ultrasaurus unobtainium. That is, oh, the Ultrasaurus could be a real dinosaur. I was going to say that really isn't a dinosaur. Snag a bonus hat for identifying what a puzzle is a sequel. What this puzzle is a sequel to. Wow. Don't know. Is it the one before it? No. I should probably remember a puzzle by Philip that had diagonals encased by other digits. I sort of do, but not really. So I'm not claiming the hat. Right, then we go on to another clover puzzle. The number 24 is a highly composite number. There are no smaller numbers that have as many divisors as it does. This makes it a helpful friend for today's 24 trio Sudoku, which is all about multiplication with a little addition thrown in on top. Normal Sudoku rules apply, and each grey line contains an arithmetic problem that must have a result of exactly 24. Multiplication always occurs before addition, so that's normal algebraic ordering, ranking. For instance, a line reading something minus something plus something. No, hang on. Sorry, I'm misreading that. A line reading something plus something times something could be filled in with the digits 9, 3 and 5 in that order, because 9 plus 3 times 5 equals 24. Digits may repeat along lines, that's useful to know. The dinosaur is a 24-carat Gorgosaurus. Yes, 24 is a special number for carats in jewellery. Anyway, the next and final puzzle is Bill's Dot Press Me. For those of you who haven't poked around the Discord a lot, I have a soft spot for the channel on monthly puzzle prompt. For those who aren't familiar, e.g. those watching this intro on YouTube, that's you people, this channel has a new prompt each month where setters will set to a theme. I haven't made anything for it in a while because I've been using my energy on gas, but this month's theme is sequels, so it feels only appropriate to post this today. If you went, oh, this is a sequel to his first puzzle for gas this month, a consecutive pairs killer Sudoku, then I love you. You can stay around. Normal Sudoku rules apply. Digits in cages must not repeat and must sum to the small corner total where given. Normal killer rules. Digits separated by a white dot must be consecutive. Digits separated by a black dot must be in a 2-to-1 ratio. Not all possible dots are given. Normal Kropke rules. And the dinosaur is a repetitive rapporteur. And that is the end of the blurbs for these puzzles. And we will revert to the first puzzle and we will restart our clocks and say the immortal and magic words. Let's get cracking. Okay, so we've got these chains of 1 to 9. So that, by the law of leftovers, is the same as that. This is not helpful. What am I meant to... Oh, this one has to have 1 and 9 on the ends, doesn't it? not 0, 1, 9 on the end. So these are 2 and 8 as we come in. The path here has to be like that, doesn't it? So that's a 3, 7 pair. This is a 4, 6 pair. We've got a 5 in the middle, and the remainder of this box is a 1, 9. I'm not sure that's really advanced us. Now this must be 1 or 9, because it must be on the end of its orthogonal path. This is 2 or 8. Now, oh, I was going to say that must be the next cell, but we could go round like that, so not so sure. Let's put in the 1, 9 here. Ah, there we go. This cell sees a 2. That's how we're going to get disambiguated. I was just thinking it was getting quite hard for a gas, but 9, 1, 2. Right, 3 now can't be here, so that's 3. That's 4. Don't know about 5. Oh, that kind of fell apart. Hasn't fixed either of these ends. Right, 7, similar to the other one, has to be fixed there. 6 there. Now what? 5 in one of those two. 4 in one of those two. Can't be anywhere else. 3, I suppose we've got a kind of bishop's move thing. 3 in one of those. 2 in one of those. Yeah, this is, I should have seen that on the other one. And 1, since by Sudoku it can't be there, it's in one of these two. And down here, what have we got then? We've got 6 and 8 in that pair of cells, which I can't disambiguate. That's 5 or 9. Ah! So it's either next or last on the line. If it's last, the line goes round like that. If it's next, you've got to get that cell. So this is always going to be 7. And this is 5 or 9 as well. Now, was that happening up here? This one was 5 or 3. How could it be 3? Oh, it could be 3. 5, 4, 3, 2, 1. Okay. I need to do something cleverer than I've been doing so far. That's a 1. Oh, that one is the missing number on the grey is 9. Ah, so we can place 9 there. That gets us done on this one. 5, 6, 7, 8, 9 in the corner. Now, 1, 1, yes, we place 1 here, but we knew that wasn't 1, so that didn't actually take us forward. 5, 7, 8, 1, 2, 5, 8, 7. We've got a 6 here. This can't be 8. I've got it as being any of 1, 3 or 5. I don't think it can be 3 because you couldn't get in and out of that corner. So it is 1 or 5. I think this has to be 3. No, not necessarily. We could go 5, 4, 3, 2, 1. No, not risking that. 8 I can place in box 3. 6, 7. One of these is a 2. I don't like that. Ah, this 9, of course, that's made it a 1. Oh, it's made the central box absolutely giveaway, and I just didn't see it. Right, 4, 9, 1, 2, 5, 8, 9. That is a naked 7. 6 in the column is there. This is a 3, 4 pair. We'll come back to that. 9, 7, 6, 3. No, we can do 8 and 2 in row 8. That's now a 4, 1 pair, which can go in. I can do the 5, 8 pair. Box 8 is finished. Less so box 7. But let's use this box 8. We've got a 6 and 7 to place in column 6. That's a naked 5 with a 2, 9 above it. Now, 3, 4 here. I can't do those, but I can do 9, 5. And that 5 is going to make this a 3. Surrounded by 2 and 4. Well, this is going to have to be 1 and 5 connecting to the 6. So that's 2, that's 4. There we go. Okay. We've got that. We've got all the labyrinths done now. We can do this 3, 5, but not the 6, 7 down here. 1, 3, 8 at the side. They all go in. 3, 1, 8, 9. This is a 2, 7 pair. Let's go across and do 9, 3, 8 in that order. 5, 7. I've got 2, 4, 6 to put in this box. Right, Let's knock off the 3, 4 while we're there. 5. Oh, I can do the 6, 7 now. And 6, 4 to finish. 5 minutes 18. I would hope that continues my quite long sequence of 2 hats. And then we will try the bent diagonal one. Right, so 5, 1, 6, 7. Oh, 5 and 6 can't be on those. So 5's in one of those two for the upper bent diagonal is what I'm looking at here. 6 has to be on all the diagonals. So and it's in the central box every time, so it can't be in one of those two or it wouldn't get on the bottom one. So it is shared in the middle. Now 5 is on this diagonal in the central box, so that must be here. Yeah, I think that's right. Because it's therefore shared between those two and those two. Okay, I'm happy with that. 7 and 8 must both be on the bottom diagonals in the central box. So that's going to be a 9. Now, this top diagonal, 6, 9, 5, the 1 has to be in that box, and the 3 and 4 have to be, oh, and the 7. Ah, the 7's literally got to be in this cell. 3 and 4. 3 is in one of those two. 4 is in one of those two. Down at the bottom, 6, 7, 8 in the central box. 5 has to be there. 9 has to be there on the diagonal. It's the only cell it can be in. So let's look at the right-hand diagonal. 5, 6. Oh, we've got a 7 on it, so that's 8. 5, 6, 8, 7, 9. So this is a 3, 4 pair. This is a 1, 2 pair, we can write them in. Let's do the bottom diagonal. We've got a 1, 2 pair left that can be written in. Now the top diagonal, 8, 3, 4 up here. Okay, that's a kind of chocolate teapot triple, weirdly. I can do this 4, 3. In fact, there was a given that meant that was never a mystery. Now I've got 2 and 9 to fill in the other cells in box 1. 3 and 4 in the other cells in box 7, 2 and 1 in box 9, and in box 3, 9 and 8, I reckon. That 8 is going to sort out my triple, 8, 4, 3, and now I've just got the central, or the even numbered, sorry, the even numbered boxes to do. And they're probably going to be quite straightforward at this point. I think we've done most of the hard work in the puzzle. 4, 3, 7, 8, 9. I know that's a 9. I don't know the other two. 1, 2, 6. That's a 1. Let's do the bottom. 3 and 1 here. Yes, they can go in now. 2, 4, 6. I can do all of them. 5, 7, 8 at the bottom. I can do one of them. And over here, 2, 7 pair in the column. 4, 5, 8 in this column. So 8, 4, 5, 1, 3, 6 up in column 7. They're done. Okay, 6, 2, 8, 7. Up at the top we've got 4, 8, 5, 8 and 1, 5, 7 to finish off. So 5, 7, 1. There we go. 3 minutes 25. So that's a good time for that puzzle. It is a little bit confusing to visualize those bent diagonals, but not too bad once you get used to it, is what I would say. Okay, Philip, let's have a look at this sequel to something I don't remember. We'll restart the clock. Let's get cracking. We've got the X here. So let's use our technique. Numbers that don't appear on the X but do appear in other boxes. 1, 5, 7, no. 2. 2 literally has to be here. So that gives here. So that gives us the 1. Now we can do 7 in the box, and we've got 8 and 9 still to go. Now 8 and 7 have to be on this bit of the diagonal. So 7 on one of them, 8 on any of them. 5 and 6. 6 has to be there in the middle. So that gives us 5. 5, 6, 2, 1. Oh, we said, hang on, why did I say 8 and 7 were there? That wasn't necessarily true, because 8 could still be there. So, sorry, that was a poor conclusion. But I can move on. safely. 3 and a 4, 9 pair. Now 5, 6, 2, 1, 4, 8, 9. 3 has to go in the middle somewhere. Okay, let's look at the other diagonal. We've got 1s missing it twice, so I can put a 1 on that diagonal. First number on it is a 1. I don't know what to do next. Maybe it's not. Ah, look at 6. 6, 6. 6 has to be in one of those, so it's missed the diagonal, so it has to go on it into the corner. Let's keep going with 6s because we get that one, and there's only a couple more. Oh, they're an X-wing. Can't finish them. I'm going to do something similar maybe with 2s, but it neither hits the diagonal nor totally misses it there. 4 is in one of those cells. 1 is somewhere in one of those. Let's look along the bottom. Right, 7 goes there, so that has missed the diagonal. Don't know. Could be there or in one of those two, so not the most helpful. This is an 8 or a 9 by Sudoku. So we've got a 5 here and a 2, 4 pair. So this is 8 or 9 as well, which doesn't really get anything done. 7's in one of those. What else have we got? Looking down columns 1, 2, 3. We've got places for 1s, 5s. 2 is in one of those two. 6, 3. Any one of those 3. I'm doing the wrong stuff now. Oh look, 2 I can place in box 2. Now I know that it is on the diagonal. Right, that could be helpful. So on this diagonal, 2, 1, 6, 5 is going to have to be here. 2, 5, 1, 6, 4, 8, 3. That is 7 or 9, just by elimination. 6, 1, 5, 2, 7, 8, 9. 3 and 4 have to be in these cells. So 3 is now shared by the 2 diagonals in the central box. One of those is a 4. That's the only place for 7 now on the negative diagonal. 4, 8 and 9. That is 8 or 9. So this is 4 on the negative diagonal. That's a 9. Got that 8, 9 pair to resolve. Okay, a bit stuck there. Let's do row 3. Left with a 6, 8 pair. Let's do row 1. 7 I can place. Ah, that has to be a 9 because it sees a 6, 8 pair. So that's put 7 on the diagonal, which was obvious if I'd considered that question. This can't be 8, so it's 4, 9. That's a 3 to finish the box. 5 is here with a 4, 9 pair. That's part of a 4, 9 pair in column 4, making this a 1. 6, 2, 4, 3 in row 8 is there. That's 8 or 9. Oh, hang on, that doesn't look good. That is mismarked. Oh, I was trying to type a 4, 9 diagonal. I was pointing out that was a 4, 9 pair. All right. I'll forgive myself a typo. Oh, you're very generous to yourself, Mark, aren't you? 3 there, 4 there. That's an 8. That's been obvious for a while. We get 9 on the diagonal, 4 there. 8 in the box, 9 on the diagonal. The diagonals are complete. And I think they're right, which is a very good way of having them complete rather than the alternative. 9 and 7, then we need a 7. That goes here, so the pencil marking tells me where 6 is. Then we can do 8 and 2. That fixes, if I could hit the right arrows, 4 and 2. 3 and 1 in this box. What have we got? 5 and 4, it feels like, left over. Yep. Not there. There. 1 and 8. 8, 1. I'm not drunk, I promise. I'm just missing my spots a few times. 9 there. Finishes that in 5:32, so slower than the first one. Very surprising to me. Hope the time is all right for that. Feels like it ought to be, but we'll see. And we'll try Trio Sudoku by Clover. Oh, different 24 Trio Sudoku, sorry. Right, so 4, those have to multiply up to 6. Are they 1, 6 or 2, 3? They're not 1, 6 because of that cell. They're 3, 2. Always start with box 1 in a clover gas. That's either 8, 3 or 4, 6. Oh, we can place 6 in box 1. Now, well, 6 is on one of those cells. Okay, these two multiply to 8, and they can't use an 8, so they're 4 and 2. These two multiply to 12. They're not 2 and 6. Do they have to be 3 and 4? Yes, they do. And now I can fill them in. I've done that in the right order. These multiply to 8. They're not 2 and 4, so they are 1 and 8. These multiply to 8, and they're not 1 and 8 because of that cell, so they're 2 and 4. Down here they multiply to 3, that's very straightforward, and this one they multiply to 4. They can't be 2, 2, so they are 1, 4. Now, has that resolved these? No. Ah, the 2 is looking at those cells, hadn't seen that. Right, 6 times can't be 1. Sorry, it could be 1. Can't be 2 or 4. It's 1 or 3. Otherwise we get too high. Well, this can't be 18, so that is a 3, and this is a 6, which is just possible. Numbers repeating on the lines was specifically allowed. Oh, that's plus plus. I was going to say this is 987, but it can't be, so there's a repeat. Oh, it could be. Yeah, it doesn't have to be 987. There could be a repeat. The lowest digit possible is a 6. And that would be here. And that would need 2 9s to be there. So that's not on it. So everything is 7, 8 or 9. Those two can't be 8s. That one could be. Now, if these are the same, that's either a 10 or 6. That's not possible. So they're different, and that is an 8. So lots of thinking about a subject that really yielded very quick, well, to what I was assuming in the first place. I don't want to say guessed. Oh, look, we can fill in 2s around the grid. Right. Maybe there's other digits I can just keep going. Let's look. That's a 3. That's a 3. That's on a line. So this line, oh no, hang on, there's a times and a plus. So 3 times 4 is not enough. 5 and a 9. 6 and a 6, that won't work. 7 and a 3, that's not allowed because of that. 8 is too much, so it is 3 times 5 plus 9. Right, that sorts out the 7, 9. Almost, in fact, there we go. I think all my lines are done. No, I've got one more here. These can't be 3 and 8 now. They are 4 and 6. And all my lines are done. Okay, so 7, 8, 9 to put in box 4. 1, 5, 8, 7 in box 1. Somehow I've overtyped a digit again. There we go. 8, 5, 9 in row 2. Yes, they can go. 7 and 4 in box 3. Let's do row 1. Row 3. Can we do box 5? 1, 4, 5. We can do the 4. I'm not risking the others. 6 there. 1 and 7. Yes, they're done. What have we got? 5 and 7 here. 7 on top of 5. Oh, I could have done 5 and 1 maybe. Oh, maybe not at this time I was looking at it. 4, 6, 1. Got a 5, 9 pair still to go in that box. I can do the 9, 5 pair in this row. 9 and 7. Along the bottom I've got 6, 8 and 5. Must be in that order. That's a 9. 3 cells to do. We go 1, 7, 5 and we're done. 4.5 minutes. So these are going pretty well today. Nothing over 6 minutes. The gas times are normally generous enough to give me 2 hats on each of those. Don't Press Me by Bill Murphy. And let's just get the clock started. So let's restart. So there's a 7 cage. 1, 2, 4. Either pair with 2 on the dot, but we need the white dot on the black dot. So we need the white dot to be obeyed as well. It's got to be that way around. Let's have a look at this one. Ooh, 21 including a pair. Yes, 8, 4. And then the 8 connects to a 9. Sorry, when I say a pair, I mean a 2 to 1 ratio. Here we go again. So that's 1, 2, 4 like that. 11. Oh, and these can't be 1, 2. They must be 3, 6 with a 2 there. Yeah, everything else would be too high. This pair, is it 4, 8? I don't think 3, 6 is high enough. That's a 4, 8 pair. The 8 touches the 7 extra digit. This is probably 4, 8, 2 with a 5 there. If it was 3, 6, we'd need an 8 there, which is not allowed, and nothing else is big enough. Yeah, okay, how about this 11 cage? Oh, we can't use 2 and 4. So it's got to be a 3, 6 pair, and that's a 2. These cages are very helpful, these little 3-cell cages. Now, got a, again, a pair there, 3 and 6 would leave a 5 here. That does work. That's very likely to be right. What would, yeah, that's the only pair it can actually be. Okay, good. All the black dots done. Now, what's this number? 5, 7, or 9? Now, these cages can't have repeats, so this is a sequence. If it was 7, we'd have 6, 7, 8, and that would be a 1. If it's a 5, we'd have 4, 5, 6, 15. That would be a 7, which it can't be. So it is 6, 7, 8. We can see the order. Let's have a look at this next. That is 1, 7, or 9 by Sudoku. If it was 1, that would be a 2, and they would add up to 19. So that's no good. So this is now 6 or 8. It can't be 8, so that's 6, 7, 13. These add up to 9 without using 6 or 7. They can't be 5, 4 because of that. So they are 1, 8 in that order. We've got 3, 5, 9 to put in. Oh, look, that one is a naked 5. And then 3 and 9 to put in the column. And in this row, we've got 2, 3, 9. Okay, these add up to, well, it's an odd number, that doesn't help. 4, 1, 8, 7, 9, 6, 3, 5. That's a naked 2. So we get 3 and 9, and that sum must work. It does. Okay. So I think we can, oh no, there's still the 21 cage. 4, 5, 9. Well, the 4 has to be there, 5 there, 9 there. That must be a 6. That doesn't work. Oh, this could be a 4 again. No, it can't. That would have to be a repeated. Ah, what have I done here, guys? 15 would need a 6 here. Oh no, don't say I've done something wrong. It must be before this. That has to be a 4, 5 pair. That isn't allowed to be 6. Let's look at the column. 1, 4, and 9. 9, 4, 1. I have done something wrong, haven't I? If I was to put a 5 there, that would need to be a 3. This can't be right because that relationship is wrong. Oh, it's right if I've got that wrong, haven't I? Wow, what a muppet. 4, 5, 4, 5. Oh, I wrote that in wrong. Okay, let's hope that hasn't killed my time too badly. At least we found the fix to make it right. I mean, I was literally thinking they can't have made a mistake. It's always me, but it is always me. 1, 7, 4. That's a 1, that's a 7, that's a 4. Let's do row 6, 8, 7, 5. That's an 8. And then a 5, 7 pair. Okay, this box needs a 5. 5, 7, 2, 8, 1. We need a 4 there. Top cell is naked. 3, 6 pair at the bottom. This is 7 and 9. We've got 1 and 8 to go in the column. 5, 8, 7 across the top, 8 and a 5, 7 pair, 3, 6 can go in here. Let's hope for no more mistakes, because I could have sabotaged my 2 hat run here, and that would annoy me more than is reasonable. A 5 and 9 here, or 1 and a 2. Right, the 5 has sorted out the 7, 5 pairs, which has done quite a lot of damage there. 9, 3 and 6, I don't know. 1 through that is 3 or 6 as well. That's a 1, that's 3 or 6. Let's do this box, which was shouting out to be done. 7, 6, 9. Oh man, why is this not going? That's become a 7, right. That's why, because I'm just not getting a bit phased, and I shouldn't let this happen when I've made a mistake, but it does. There we go. Oh, 6 minutes and 3 seconds. Unless that puzzle is easy enough to be one of the few that is granted a 6-minute 2 hat time, I'm all right. And it was quite easy once you started considering these 3 cell cages. I think I ought to be all right, but if I've missed it by 3 seconds because of entering that pair the wrong way round, well, I'll be the numpty I feel, which is entirely possible, but whew, it's a relief to get there in the end. That was quite innovating in the finish, but very pleased to get through them. Fabulous puzzles as always. Really enjoyed those today. Bit of a throwback in some ways. Obviously there are sequels there to puzzles I dimly remember solving. But I don't know exactly which ones they were, and I'm sorry if you expect me to. I'm talking to Bill and Philip especially there. Thank you for watching the channel as always. It's an absolute pleasure to have your company for these, and hope to see you again soon. Bye for now.